Thank you, and welcome. Welcome to today's webcast, Resolving the Municipal and Utility Infrastructure as-Built Backlog. Again, my name is Mike Schlosser, and I'll be your host for today's webcast. Before we get started, I thought I'd give you a little bit of an introduction to myself. I'm actually a professional engineer as well as a GIS professional, and I'm an Autodesk technical specialist. I've really been working in the industry, both engineering and geospatial, for the last 20 years or so, and I've been with Autodesk for the last 7 years. And my focus has really been on combining the engineering and geospatial techniques for how we manage our above and below ground infrastructure as it pertains to municipal governments, utilities, and so on. I'm actually based in Regina, Saskatchewan, and for those of you that don't know where that is, that's in the Great White North in Canada, and the view that you see, that picture that you see at the bottom of the screen there, that's what it looks like just about 5 or 10 minutes away from my home in the summer. It's not the way it currently looks today because it's apparently minus, 25 degrees Celsius, I think, in Regina, so I'm trying to stay warm. Anyway, that's a little bit about me. For those of you that are on Twitter, you can also follow me on Twitter at ENGIS, which stands for Engineering GIS. So let's continue. When we think about the infrastructure as it pertains to municipalities and utilities, there's a basic need that has to be fulfilled, and that need is to create, operate, and maintain our above and below ground infrastructure within budget and to agreed upon service levels. And when we think about meeting that need, there are certain problems that come up, and some of those problems deal with the lack of data standards, the lack of integration that comes up between different types of technologies, different types of information, and sometimes a lack of currency, a lack of having up-to-date information, all of which impacts budget, impacts operations, impacts maintenance as it pertains to really creating, operating, and maintaining that infrastructure. So with this in the back of our minds, I wanted to present our agenda, and that agenda is to review the as-built problem. What is that as-built problem, and how do we go about resolving it? And in order to put this into context, we're going to start off by just briefly looking at some of the industry challenges, as well as then dive into what this as-built problem is and what we can do to solve that problem. At the end of this presentation, our hope is that you'll come away with some key piece of information that will help you start processes, procedures for resolving the as-built problem within your own organization, and maybe discover ways where you too can improve data currency or improve access to the data that you have that pertains to infrastructure, and ultimately provide improved confidence in the data that you have so that you can have better decision-making take place. So that's our agenda. Now, with that, before I dive too much into the presentation here, I wanted to ask you a question, and hopefully through this poll, get a sense of what our audience makeup is. If you could go in and select what your primary industry might be, that would give us some help as well. There you go. So you can see the results here where most of us are municipal public works professionals. That is our primary industry anyway. And you can see that that's followed closely by water and wastewater with a fairly large group or a similar size group in other. Thank you for giving us your answers to that. Do you feel that you have an as-built backlog? And if you don't know, that's fine. Simply answer don't know. give you a few moments to answer that question. So there you can see the results. Again, thank you very much for that. I appreciate that. All right, let's go on with the presentation here. So in terms of our industry challenges then, there are a number of them. I know we've all heard many of these challenges in the past. We've experienced many of these challenges such as the aging infrastructure. All we have to do is drive down the roads. All we have to do is open the newspapers, and we see evidence of the aging infrastructure. And the fact that there is an infrastructure deficit, that is, the dollars available to put into correcting the infrastructure, bringing it up to grade, just isn't there. And so that is a big industry challenge. Another industry challenge deals with knowledge transfer, whether it's due to retirements. Utilities in particular are being faced with the challenge of making less experienced workers productive sooner, bringing in new people to replace the retirees. So to mitigate the potential for a shortage in experienced professionals and reduce the learning curve for new workers, new ways of thinking are required. New tools are required. Training is required to try to bring these folks up to speed. And yet that all is on top of the other challenges that are there, such as rapid change. I mean, it was just a year and a half, 2 years ago, where it seemed like the booming economy meant that there was no slowdown whatsoever in terms of infrastructure projects, and we were all scrambling, trying to get as much infrastructure out there as quickly as possible. Lots of things have changed since then, and yet rapid change continues, maybe not in the infrastructure build-out, but in terms of trying to address other kinds of changes dealing with the global changes in weather patterns, climate change in particular, or even as it pertains to technology. Regulatory compliance is there, whether you're from the U.S. or from Canada, since this particular webcast is addressing both sides of the border. Regulatory compliance is important. Those folks in Canada have recently experienced a new regulatory measure called PS 3150 that has come into play. And so there are certain requirements for that regulatory compliance that needs to be dealt with, again, from an infrastructure perspective. And then, of course, there's the economy. The economy is still front and center in the news, and there's actually an interesting piece of fallout that comes from that, and that because of the build-out not being as rapid as it used to be, because there's not a whole lot of new infrastructure being demanded now, there's perhaps a slowdown in work, and that slowdown is presenting us with opportunities to go in and perhaps think about how we can become more efficient at what we do, opportunities for us to actually put some of these as-built backlogs that we've been accumulating and start addressing those as-built backlogs and maybe put more dollars towards the repair of existing infrastructure. So another aspect that we need to think of is this particular chart here, which talks about declining productivity. Now, it's interesting, if you take a look at this blue line right here, this blue line represents non-farm productivity. And this non-farm productivity, think of it as industrial type of activity. So the creation of, over the 40-year horizon, that productivity has essentially doubled over that period of time. And why is that? Well, the industry has become more efficient. They've taken things like CAD drawings, and they can press a button, almost literally press a button, and instantly send this CAD drawing off to a robot, and the robot goes and builds whatever that widget might be. Now, if you take a look at the red line, though, the red line represents construction productivity. So whether that's the creation of buildings or the creation of bridges or other kinds of infrastructure, the important thing here, over that same 40-year horizon, productivity has declined. Now, why is that? Well, for a lot of us, we still print things to paper. For a lot of us, our construction projects have really become a lot more complex and yet not kept up to date with, or the implementation of those processes have not kept up to date with the complexity of those some of those projects. So we really need to think about why there's this separation, this divergence in these two lines, and try to bring that red line back up above the 100% mark. Now, the next slide talks about inadequate interoperability and the cost to folks, whether they're engineers, whether they're contractors or suppliers, and those costs, how they impact our owners and operators as well, to the tune of $9.1 billion. That's what the lack of interoperability between moving information from, let's say, the design, planning, and engineering phases to the construction phase over to the operation and maintenance phases. And the as-built problem is actually part of this lack of interoperability that we see here. Notice that the owner-operators, whether it's the owner of a building or the owner of the utility or the municipality that eventually might own some of these utilities, the bulk of the costs are in operation and maintenance, and the bulk of the costs are absorbed by operators, the owner-operators. All right, so who are these people that are impacted by the as-built problem? Well, there's a whole variety of people, whether they're executives, who need to see the big picture, who rely on up-to-date information for better decision-making, or the city engineers or public works people that need a better way of managing the infrastructure. They need a better way of really dealing with the as-built backlog. These are folks that are familiar with CAD tools, GIS tools, and so on. Maybe it's their maintenance and operations staff that have to go out there and deal with maintenance requests or outages and be able to deal with that more effectively. They're also impacted by not having up-to-date as-builts. Maybe it's the GIS folks, the mapping professionals who need to populate as-built information into their corporate databases. And what kind of hoops do they need to jump through in order to make those CAD drawings into information, into data that can be used corporately to make decisions? Even finance departments are in need of current information, information that reflects the regulatory reporting requirements that they're subjected to about the state of the infrastructure and the value of that infrastructure. So there's a variety of people that are impacted. Where do you fit in that potential impact? Now, all of these folks are interested in trying to determine something about that infrastructure. What we did here is we just put together a short list. The text is kind of small, but and I am not expecting everybody to read every line here. But what's important here is that when you start taking a look at this data and trying to extract keywords, you can see things like out of date, risk, confidence, and currency. And when you take all those words together, they really can be narrowed down, boiled down into one phrase, and that is the phrase of data currency. So let's take a look at this data currency process impacts that. So right now, when we take a look at the as-built problem, really what we're talking about is the delay in entering as-built information into our corporate databases. Sometimes this delay is just a few months. Sometimes this delay is several years. So, do you think that the delay is less than a month? And really, for all intents and purposes, a 1 month delay means that you don't really have much of a backlog. Or is your backlog manageable? It's less than 1 year, and yeah, okay, it's not as great as you might want it to be, but it could be better. Or is backlog between 1 and 2 years and it is reason for concern? Or is it as bad as, you know what, our backlog is greater than 5 years and, you know what, it's completely unmanageable right now and we have no idea what it's going to take to get caught up? In other words, everyone on the call has a backlog problem. And not much of a surprise, we've talked to several organizations and have had several conferences, in-person conferences, where there were very similar results. The bulk of the people are hovering around 1 to 2 years or so, with some people out there being greater than 5 years. So thank you for sharing those results with us. If we take a look at the as-built workflow problem, maybe we can figure out why there's an as-built problem. So here we are. I've created a simple flow chart, if you will, of the as-built workflow. Typically what happens is we have a new development. We start off with preparing a base map where we have some infrastructure data. We grab some parcel data, some developer plans, and we might either go to some in-house design work or go to a consulting firm where they do some design work for us. They're the ones that then create the drawings that eventually go out to tender. And so that's when we start, once we have that tender, we go out to construction, and then once something's been built, we go into records management and start taking that as-built information. We send somebody out to that construction project. They collect some information about what's been constructed, and maybe they pick up things like that manhole, rather than placed 10 feet away from the property line, was actually placed 12 feet away from the property line. So we collect that information and update our drawings, our CAD drawings with that, and then we take those CAD drawings and give them to the records group, where they then put it into their corporate databases or their GIS repository. Part right here contributes to the as-built backlog. It's that process of waiting for the as-built after construction. It's that process of taking those drawings, working through the drawings, and then bringing that information from the drawings into the corporate repository that contributes to the backlog. Well, what causes that? As I mentioned, sometimes it's just a delay in the creation of the actual as-built drawings. Construction has gone ahead, the project has been completed, and yet it might take months before a consultant or some other organization actually makes it to the field to collect the information about what's actually been constructed. And yet, you're already starting to maintain the infrastructure that's been built. So that's one source of the delay. Another source of the delay could be the fact that things are still being printed to paper. In other words, that as-built drawing that you get from the consulting firm or that as-built drawing that you're creating yourself is being printed to paper, and somebody is going out there with a red marker and writing in the details of what's changed from the as-tendered or as-designed document to the as-constructed. And it takes time transferring that paper information into a digital environment. And then third, there's poor CAD and GIS integration takes place. I mean, you've got information, ideally, in a digital form, perhaps in CAD, and perhaps that CAD is intelligent CAD. It has the correct information that somebody needs to populate a corporate database. And yet, there is an integration issue between one CAD platform and one GIS platform. So is there a way to overcome these particular problems? Well, when you think about all of the pain associated with the lack of currency, the pain that happens as a result of the as-built backlog, this increased risk occurs because you're making decisions perhaps on out-of-date information, or maybe you have these inefficiencies that result when somebody has to go out and they know that the corporate database is inaccurate or at least not current, and they have to go and find all of these paper documents to verify that something is actually the way it is in the field. Or maybe the folks that go out and do a maintenance report, work order, do a maintenance work order, they're going out in the field thinking that they need one piece of equipment, and yet when they're out there, they discover, oh, they've got the wrong piece of equipment because the corporate database was out of date. Now they have to go back to the office, the warehouse, wherever, pick up the right piece of equipment, and then go back out in the field. All of this leads to inefficiencies and potentially even public safety issues. So what is it that we can do to solve the as-built problem? So I need to issue a warning at this point. This warning is that there's a new way of thinking ahead. And that new way of thinking is going to shake up various departments within your organization if you were to approach this. But this new way of thinking is also free. The idea that I'm going to discuss now is free. You don't have to buy anything. You don't have to buy anything from Autodesk or anybody else in order to implement this new idea. But here it is. Rather than going with an as-built work, an as-tendered, or as-designed workflow. What I mean by that is as soon as you have that tender document, rather than waiting until that piece of construction has been completed and then creating an as-built, take the as-tendered document, that design, that work order information, and use that to update your corporate database. Then, once something's been constructed, use the as-built whenever you get it. Could be months, maybe longer, later before you get this information. Whenever you get the as-built information, use that to update your records database. So this is going to help you achieve currency. And the way it's going to help you achieve currency is because you're putting information into the database before it's actually been built. Now, I know what you're thinking. You're probably thinking, you know what? I can't do that. I can't mix what's real, what's live, what's actually been built in my database with what's been proposed or what's been tendered. I can't have somebody go out into my database and confuse what's not real, what hasn't been built yet, with what is real. Well, I'm going to show you how you can do that. And you do that with jobs and versioning. You can actually take as-tendered and as-built information, use that together by assigning versions to your data. Again, this is free. You don't have to buy anything to implement versioning of your data. What I mean by this is that when you first get your as-tendered information and you use that to populate, you assign a status to it, a state, if you will. Call it an open state or an as-tendered state. Now, only people that can view as-tendered information would be able to view this information, and you would not have to worry about those folks that need to see live information ever seeing this open information. Think of it as two different views of the data. Now, when something's been constructed, all you have to do is take that as tendered information that's been already loaded into your database and elevate its state to pending. Pending approval of the as-built, verification of the as-built document. Now anybody that can view that kind of information will be able to see that, but they will know that this information is pending verification. And that's really important to be able to distinguish that information from what's live, what's real, what has been checked, with what's live and real that hasn't been checked. Once you do get your as-built information, you can then simply make the minor changes. It might be repositioning that manhole slightly, or it might be changing an attribute that says, you know what, it's a particular type of manhole as opposed to the one that was originally designed. And those changes are very quick and easy to make. And at that time, you elevate estate to lot. All right? So to show you what I mean, I'm going to give you a demonstration. In this demonstration, I got this potential new development, and this new development has gone to tender. What I'm going to show you is how we can combine information coming from many different sources, such as from a corporate database source, as well as other GIS sources, as well as bring in design information coming from a CAD drawing, and then using that information to populate my corporate database. I'm going to show you what happens when I populate the corporate database not using versioning, and I'm going to show you what happens when I populate the corporate database using versioning and why that's an advantage. All right, so what I'm doing is I'm using software called Autodesk Topobase. And Autodesk Topobase is actually built on top of AutoCAD Map. As a matter of fact, here you can see that I currently have a map task-based ribbon workspace, and for those of you that are familiar with AutoCAD Map will recognize this as AutoCAD Map 3D 2010. What I'm going to do is actually change my menu environment to be a Topobase environment. And what that does is really configure this environment so that I can take advantage of the data models and the workflows that this Topobase environment gives me. So let me connect to some data. What I want to do is I actually want to bring in an aerial photograph to show you the area that I've interested in doing a development on. I've got a small subdivision development, just a few parcels, and I want to make sure that by bringing in this raster data, I am actually working with a vacant parcel. And so what I'm doing is I'm going to connect to some data. I'm not doing an import or anything. I'm simply connecting to the data, which means that in this environment, things like projections and size of files and so on are dealt with for me by Topobase and AutoCAD Map 3D. So here you can see my aerial photograph. You can see some of my infrastructure data that's there. What I'm going to do here is I'm just going to quickly change the draw order here so you can see the parcel information because my aerial photograph came out on top of everything. So I'm quickly just going in here and grabbing these parcel lines and throw them on top of my aerial image. There we go. So here is the parcel of land that I'm talking about right there. So you can see it's vacant. Now what I want to do is bring in some additional information. Let me show you these buildings. These buildings, building footprints, are actually coming from my Topobase database. So the line work and so on coming from my aerial photograph coming from my raster image. So now what I would like to do is actually start working with this tender document, this design document for the construction that needs to take place. The way I'm going to do this, I'm going to use a feature within Topobase as a result of Map 3D, being on top of Map 3D, to attach to a drawing. Rather than opening a drawing, I'm using this feature to attach to a drawing so that I can query the drawing. Now I'm just going to quickly set up a query here to retrieve all the information in this drawing. And you can see I have some contour lines, I have some parcel lines. Looks like I have a scanned document in here. So yeah, I've got a scanned document and so on. So I don't need all of that information. All I really need is the building footprints and the lot lines. So I'm using the ability to query to say only show all that other stuff. I just need the building and the lot lines. So I query a drawing. What that means is I've really treated the drawing like a data repository. I'm treating the drawing like data. Okay, so let's go back to this Topobase environment. How do I add this CAD data to my corporate database? Well, the way I do this here is simply point to a workflow that says, you know what, I have some feature data here. I'm going to use this CAD-based line work and simply populate my database with it. I simply select the line work and tell it to go ahead and populate my database. Let me do that again for the other three buildings here. click on the line work, tell it to populate my database. Now, you see the message that's coming up there. It's saying, do you want to update my save set? This message right here, add objects to save set. That's telling me that, you know what, if I'm making changes, do I actually want to save those changes back to my CAD drawing? I'm saying, no, I don't. I want to keep my CAD drawing exactly the way it is, but use those entities to populate my corporate database. And by doing so, Interoperability has automatically added details to that, attribute details, that I can then use a form to modify what those attribute details are. So in this case, I'm just changing the type of building very quickly to building and tell it to add that attribute to all 4 buildings. Now, what did I just do? What I just did is I took a tender document, something that hasn't been built yet, those buildings have not been built yet, and I've added that to my corporate database, and that is not the way I should be doing it. What I should be doing instead is using versioning. So what I'd like to do is show you how we can use versioning to deal with the utility infrastructure. In this case, I'm highlighting a water main. This water main has a bunch of attributes associated with it. So if I just bring up the form, you can see here there's, I don't know, there's some cathodic protection fields there. There's some material fields, ownership type fields, things like that. So we have these pick lists all being driven by the database, all attached to that water main. And yet I need to add, let's say, a house connection to each one of those buildings. So within Interoperability, we use workflows to do that. So here, for example, you can see I have a house connection workflow, a fire hydrant creation workflow. Well, I was talking about versioning and how to keep things separate. So what I want to do is create a job. Jobs within Interoperability deal with versioning. Here you can see the live, pending, and open states. I'm going to create a new job, give this job a name dealing with this proposed development. We'll call it proposed water connections. Now, jobs can have a geographic boundary, and jobs are there so that we can go in and edit those jobs, any changes that we make, as we go through the process of adding this as tendered information. In this case, I'm actually going to create data without going back to the CAD drawing. What I'm going to do is simply use a workflow that says, let's use these house connections right here and create a straight pipe that connects from the house location right there to this pipe. Notice I'm picking somewhere on the pipe. And Interoperability automatically creates that straight pipe for me. It will split that water main that I'm selecting. For example, this one right there, you can see how it's now a little bit shorter. It's automatically taking care of ensuring that all of the corporate records are automatically updated within this particular job. I'm not affecting that original water main in the live mode. I'm only affecting it in this version, keeping it separate. That's what we want to do. At the same time, I have information, just like I did with the buildings, associated with those house connectors that I just created. So I created 4 house connections to deal with those 4 buildings. So I can do a global update again and say, for example, let's grab this one here. Say that it happens to be a private ownership. Or maybe grab the owner's name here and assign all 4 of those house connectors to Joseph Ackley. So I've quickly done an update. The point is, all of these forms are available to me as part of the workflow. And I can do the same thing for the pipe. For example, if my workflow says I don't need to fill in all of this, maybe I only have 2 or 3 fields that I have to fill in, then that becomes my workflow. The important thing is I'm dealing with this as an as-tendered document, not impacting or waiting for the as-built information. I'm populating this based on the as-tendered document. Okay, so I've created these house connectors. How do I know I've created these house connectors in a way that is topologically correct? In other words, how do I know that these, let me just turn this building layer off here so it makes it more obvious. How do I know that this house connector right here is actually connected to the rest of the network? How do I know that those pipes that were just created are connected to the rest of the water mains? Could be power, could be gas, what have you. So I'm just picking a start and an end trace so that I can verify the connectivity. The workflows, by the way, have ensured connectivity. I'm just verifying it for my own sake. And here I can see that, yes, indeed, I have 4 house connectors and that it did a trace, not only based on the lines, but on all of the connected appurtenances to that network. So here's that building, there's the house connector, and you can see that, yes, indeed, it is one of those elements that have been traced. Advantage of doing it this way versus the old method of waiting for as-built. Well, what I'm going to do here is I'm going to switch to the web. I'm going to launch a web application called Topo-Based Web, and let me authenticate this. Simply come in here and grab that same water network. I'm not going through any import-export process here. What I'm doing is I'm connecting to that same central data store that I was connected to through Topo-Based earlier. So we'll just quickly do that. Let me zoom into that same location that had a proposed development. Let me come in a little bit closer here. So here you can see my proposed development. Now, you can see the impact of not using jobs or versioning when I entered the building. I don't want to display those buildings at this point because those buildings have not been constructed yet. So this is an example. You don't want to mix with what's live with what's real. But interestingly enough, let me just grab my drawing information, my CAD information, and lay that on top of this environment here so you can see the parcels here. So those parcel lines are actually coming from the CAD drawing, so I'm just showing you that here. But where is my utility information? If I turn on the utility layer, you can see the water main out front, but where are all of the house connections and the lines connecting those house connections to that water main? They're not there. They're missing. Where are they? Well, let's take a look at this building, for example. We are still connected to that corporate data store. So if I select that building and look at the attribute information for that building, we can see that, yes, indeed, it is a building, and the type is building. That's the information that I added when I was at the desktop, but the information for the water network isn't there. Well, the reason for that is if I turn on the water document, give that a second to turn on. Again, I'm browsing this through the web right now. Everything that you're seeing is through the web browser. You can see that the job is currently set to live. So live is live information. I've just chosen the job to be proposed water connections instead. And now this is the job. This is the versioning that I was talking about. So only somebody who authenticated properly can see this version data. And that's what we want. We want to be able to control the versioning and elevate the state of that versioning when it's actually been constructed and maybe change it to pending at some point. Now, again, we have all of the attribute information at our disposal. So here you can see Joseph Ackley is actually assigned to that house connection. I can come in here, even through the web, and change that to, let's say, Michael Twitter. And so there we go. We've updated that information now, and Michael Twitter is now the proud owner of that house connection. Even though we're with the web, we can even go in and create or edit geometry if we're properly authenticated. So, for example, maybe that pipe did not get built, and so I actually changed this house connection, this pipe, and eliminate that pipe through versioning. I haven't impacted anything else that's live. And even though I'm still connected with the web, I can do a trace on this pipe network. For example, I just finished deleting a pipe. I finished editing some attribution. Did I break any topology at this point? Did I break any connectivity? Well, let me do a trace over the web on this same network. I pick the start and ending points for the trace. I tell it to go ahead and execute that trace. Wait for a few moments while it does its trace over the web. And here we go. You can see that it is actually reported on the appurtenances, such as those house connectors, that it can now get to. Notice that we only have 3 house connectors now, not 4 like we did before. The reason for that is that one of those house connectors no longer has a pipe connecting it to the rest of the network. So here if we click on one of them, you can see that we've zoomed in to the house connector that it was able to trace to. And there you can see the other one that it wasn't able to get to. Let me just move that. All right. So let me come back to the slide demonstration here. Now, what is it that we just saw? Well, as a result of using versioning, we're able to get ahead of the as-built problem. We can separate what's real with what's as tendered, which gives us a whole bunch of increased flexibility. In the winter months, when construction is at a slow or virtually non-existent in some places, that's the time when you can start entering some of these designs that are coming into play. In the summer months, when all kinds of construction activity is happening, that's the time where you can focus on construction and you can still elevate the status from as tendered to it's constructed, but it needs to be verified. And all of this will help improve data currency, ultimately improving decisions. So, wanted to bring up an example, a real-life example. City of Saskatoon, I'm based in Regina, Saskatchewan. The City of Saskatoon had a problem with as-built data that was at least 5 years out of date, and they too needed to mitigate the impact of this as-built backlog. And so what they did was they decided to implement a first-as-tendered approach to adding this data to their corporate databases, and then use the as-built information to update the changes that were necessary. So they used the first-as-tendered, then as-built approach. Well, if you take a look at the results are actually stunning. I mean, for paper as-built, whereas before they'd have to go into these drawers and find these paper records, and they improved the efficiency of searches by 20%. But they also improved the accuracy of their infrastructure inventory on new construction by 15%. Now, the spin-off benefits are perhaps less tangible, but they are very important in terms of what their impacts were for regulatory reporting, decision-making, and public safety. Now, some of you may know this gentleman. His name is Glenn Bowes. He's with the City of Saskatoon. For him, I mean, if you read this quote, he basically said, greater risk occurs in the absence of data than having too much information. And that's as it pertains to solving the as-built problem using this first-as-tendered or as-designed approach. So, in summary then, I just want to say that, you know, we used Autodesk Topobase 2010 to demonstrate this idea of using versioning to deal with the as-built problems. But Topobase is built on AutoCAD Map 3D. Regardless of the software that you're using for CAD or your corporate database, though, you need to ensure that your CAD drawings, your design drawings, are properly structured. That means CAD standards have to be in place that not only address the idea that things are on the right layer, that you're using the right blocks or symbology, but that you actually have lines connected at their endpoints and that there are unique identifiers attached to your appurtenances and design elements. You also by implementing an as-tendered approach to this, you're actually resolving a step towards that. And remember that versioning is really what separates what's real and what's proposed. And I do not recommend that you throw all this information into one database without any sort of versioning in place. So, wanted to give you a final thought, and that is, remember that what you do upstream affects what happens downstream. So as you go through the planning, the design process, making sure that part of the design process you are looking at intelligent CAD drawings. As you're moving into construction, that you're keeping things digital rather than moving things to paper, and that you're actually moving that information into the corporate database ahead of the operation phase. And as you're dealing with operation and maintenance, that you're taking advantage of this digital information. So you can see how even in the real world of, you know what, if you pollute upstream, it's going to affect everyone downstream. Putting inefficiencies into a process early in the process impacts everyone downstream as well. Remember, that $9.1 billion interoperability problem, that's a huge problem, and many of us are facing our own portion of that problem. That concludes today's webcast. I know that Warren has been on answering as many questions as he could. My name again is Mike Schlosser, and with Autodesk. If you want more information, I've got a few links here. I have a personal blog. It's called geoexpressions.blogspot.com. If you're interested in more information on the as-built problem, there are some sources there, as well as you can visit some of the links below directly from Autodesk.